All right, today we're doing section 1.5 on segments and their measures. Here we've got some vocab. You should have picked up a vocab sheet. If that's not enough room to fit it on there, you can put it on the vocab organizer. All right, our vocab words today. Coordinate, a real number that corresponds to a point. We saw some of those in the warm-up. Distance is the absolute value of the difference between 2 points. It's important to remember that difference refers to subtraction. So if you are unfamiliar with that or forget those, difference means we're subtracting. Length is the distance between the endpoints of a segment. Between or betweenness is how we describe collinear points that are in between or within the endpoints of that segment. And congruent segments are segments with the same exact length. Okay, our postulate for today is that if B is in between A and C, then AC is equal to AB plus BC. So we have a diagram that illustrates that. The point B is in between points A and C on a segment. So the whole length of it would be AC broken into two pieces. So down here you could replace AB with AC or BC. It's generic. AB without a bar over it, like we see in the postulate, refers to the distance between points A and B. AB with a bar over it refers to the segment that connects A and B. Okay, so when we are referring to AB without a bar, that's usually going to be a number, a length, a distance. AB with a bar is referring to an object. Those are two separate things. You need to be able to keep them separated. So if you are asked for a distance, you should not put the bar. If you are asked for a segment, you should put the bar. Okay, I understand the notation gets very nitpicky in geometry. Sorry, it's just kind of how it is. In order to find the distance between Athens and Albany, we are going to have to use the addition postulate that we just learned on the previous slide. This is probably a problem you would have seen in elementary school. We know how to get from Athens to Macon in the middle there, and Macon to Albany at the bottom. In order to find the whole distance we need to travel, we are going to add those numbers together. So, to find the length of AB, I need to take the length of AM and add it to the length of MB. That is how I will set up this problem. Then all I have to do is plug in those numbers, 80 and 90, to get a grand total of 170 miles. Do we have any questions about example 1? In order to find the length of PQ, we again are going to use the addition postulate. So to set this up using the addition postulate, I know that the length of PR is equal to what two segments added together? I need a hand. Mariah. PQ plus, wonderful. Okay, who can tell me what to plug in for PR? Honesty. 12 equals, who can tell me what goes in for PQ? need a hand. What goes in for PQ? Julian. Do I know what PQ is yet?
No.
No! When we don't know something, we should just leave it as PQ. If you really wanted to put a variable there, you could. I understand this might seem tedious for this particular problem, but going forward, we need to understand how these problems are set up. And who can tell me what to plug in for QR? Nikitra.
7.
Wonderful. Now, what we have on our hands is a basic equation from algebra. So in order to figure out what PQ is, we will subtract 7 from both sides. So as many of you knew from the moment I drew the diagram, PQ has a length of 5. All right, so once again, I want to set this problem up using the segment addition postulate. So before I even start caring about my numbers, I know that AC is equal to which two segments? AB plus BC. Now I'm ready to start substituting things in. Do I know AC yet? No, so leave it alone. If you really want, you could use a variable. What's going in for AB? What's going in for BC? So for AC, I have a length of? Wonderful. We are going to plot the coordinate points and then decide if AB and CD are congruent. I know I emphasized it before, so really these should have the bars over the top of them. We are referring to these segments. So A, B, and C, D should have the bars over them. Okay, so I'm going to take your help in plotting these points much like we did on the warm-up. So who can tell me how to plot point A on problem A? Someone I haven't heard from yet today, perhaps? Shelby, can you help me out? So for point A, I'm going left 2 and up 3. I'm going to label that point. Who can help me out with B?
You do it.
John?
A. Okay. So you do the thing over +3, and then you go up +3, and then you got B.
So go over which way? You said go over 3.
Yeah, you go with +3, and then right,
Oh, okay, right 3 and then
and then you go up +3.
wonderful. Right 3, up 3. There's point B.
B.
I'm going to go ahead and connect those to make that segment. All right, who's helping me out with point C? Joshua. Starting at the origin, where do I go to get to point C?
Go -3, then on 4.
When you say -3, which direction do you mean?
To the left.
To the left 3 and then up 4. Very good. I'm going to use a different color since I've got a different segment. And it's really close to that point A. So there is C. Now who's helping me out with point D? IKEA. And very good. Left 3, down 1 for D. Again, I'm making a segment out of those 2 points. Now I have to decide if those segments are congruent. What do we think? Because we can count that both of them have a length of 5 units, even though they're going in different directions, they are congruent. So we would say yes. There is a special symbol we can use to show congruence. We'll talk about it more later. But we could say segment AB is congruent to segment CD. This symbol means congruent. John, you already went. Would you like to go again?
Yeah.
Okay, how do I get to point A?
So you stay on 0,
Mm-hmm.
and then you go up 5,
Wonderful.
and then you got A.
Perfect. There is point A. Who can help me out with point B? Sydney, point B. How do I get there? Wonderful. 0, -1. We just go down 1 from the origin. That is point B. And I will go ahead and connect those to make that segment AB. All right, who's helping me out with point C? Kiatha, point C. Over 4 which way? To the right 4, and then that's it. You stay there. There's point C. Who's helping me out with point D? Angel? Left 1, and then that's it. Okay, that is point D. Again, we connect them to make the segment. And we have to decide, are they congruent or do they have the same length? In this case, the answer is no. Okay, we've got a length of 6 and a length of 5. Those are not the same length, so no, they are not congruent. That is the end of our lesson today.